Hey there, welcome back. And in this video, we're going to talk about using the photoresistor or the light sensor to get the values of how bright a light is. This is part of lab 3, I think, for MEC 215. But it's just, there's some concepts here that will be useful for your final and will be useful for your final project as well. So in this video, we're going to go over averaging data in 2 different ways, and also obtaining the noise level in a depending on the sample size that you choose. And the reason why we talk about getting the averaging the data and noise level is because when you're working with something like the photoresistor, if you point it directly at the monitor, it's actually not always going to be reading the same value. It kind of fluctuates quite a bit. Depends. Sometimes there are photoresistors that are a little better, but it usually anyways tends to fluctuate quite a bit. And the idea is that you want to have something super stable so that you can map it to real world applications. So like, for example, if I have a light a light sensor and I have my hand here, I can actually calculate how close my hand is to the light sensor by mapping distance to the input of the sensor, and it's just going to be a lot more accurate and a lot more useful if we average that input out before using it. So the 2 ways we're going to do it is one, summing sum of input in a sample, or let's say average in a sample by adding all values and dividing by size, doing the value, like max plus min value divided by 2, and then we're gonna also talk about noise level. Okay, so now that we got that out of the way, let's go ahead and just show you sort of what I'm talking about when I'm saying that it fluctuates. So I'm going to serial.println the input from my sensor. Now what I'm using is the photoresistor. So if you don't know how to wire it, I recommend you just look up photoresistor Arduino, and it should be the first link here. You can see it over here. I use this exact same setup. So if you look at my, and I'm just gonna move my camera down over here. You actually can't see much, but let me get it closer. So I have my photoresistor here, my resistor over here. My yellow cable is what their green cable is, so it's a data cable. And then I use red for power and brown for grounding. Now I connect my red and my ground from the photoresistor to the ground and power rail on my breadboard, because there's a chance that I actually need the power rail and the ground rail for the servo in a future tutorial. So I just set it up right away. It's going to be a lot easier to work with anyways if I do that. But you don't have to. You can just follow this exact the picture you see. Excuse me. The picture you see in the article that we're seeing right there. And basically I do red goes to 5 volts, brown goes to ground, and my yellow pin, which is my data pin, is going to go to A0. This article is going to be in the description below, so if you need to use it to reference, just go ahead and take a look. So let's just go ahead, upload this, and open the serial plotter. Give it a second. I actually don't know if I opened it. There we go. And you can see that it's very, it fluctuates quite a bit. If I put my hand over it, it looks a little bit smoother, but the moment it zooms in, look. And the more I move it, it's just like, it's all over the place, right? So the idea that of what we're going to do is we're going to try to smooth out these spikes by getting the average. So to do that, we're going to create functions, okay? Now, the way I create functions is first I ask myself, sort of what am I returning, what's the value that I'm getting from that function. In this case, if I'm averaging a sample, if I add a bunch of numbers and I divide it by another number, it's most likely going to be a decimal, so I know the type is going to be a float, and then I'm going to name it read voltage sum. And I'm going to keep it like this for now. Once I have this, let's talk about what it is that exactly that I need for this. So I need some way of storing the sum, and I need some way of storing the sample size. I don't really think I need anything else apart from that. I'm just gonna create my sample, add all those numbers, divide it by sample size, and we're gonna call it a day. So for the sample size, I'm gonna use the variable n. And I'm going to use 1,000. 1,000 is a very standard number that we use for this lab. You could change it. You could put 500. You could put 20. And later on, we're going to explore what exactly that, what does it change in terms of your input values. And then the second thing we're going to do is we're going to create a long sum equals 0. The reason this is long is because int is not big enough for 1,000 samples. It actually the buffer is not big enough, so it kind of restarts. It overflows the buffer. That's the word I was looking for. Once I have these two variables, all I need to do is for int I equals 0, make a loop basically that goes from 0 to 999, so 1,000 times, and we are going to sum all of my analog readings, so A0. Right now I have 1,000 values that I summed up. So how do we get the average? All I have to do is sum divided by n. Right, and now here all I have to do is read voltage sum. Call the function, and once I upload it and I look at my serial monitor, actually serial plotter I should say. Okay, let me close it. Duals serial plotter. You can see how much less spiky it is, right? There is one spike here and there, and the value still goes from 600 to 620 as it was before, but no, it's no longer doing this sort of spiky thing. It's just going like up and down, and obviously right now it's going up and down because I'm covering it. That's what the big spikes are. It's not because of the averaging. But yeah, this is a very, very useful tool to use. You always want to average it out. Obviously, if you decrease this number, it's going to be spikier, right? If you increase it, it's going to be smoother. But you don't want to increase it too much because then it makes your program really slow, because you're basically you're busy. You're using your computer to do 1,000 times. You're not doing anything else for that for loop. It's not like your timer, which we talked about last video, where you can run other things in parallel. This, when you're reading your voltage, it's gonna take 1,000, let's say, frames or 1,000 ticks to compute this. So yeah, pretty simple, but this is a very, like, you're gonna see this in your final. They're gonna tell you to sum, you know, all the values in an array, for example. So you're gonna have to create a variable that holds the sum. You're gonna have to add them all, and then maybe even compute the average. So but it's pretty straightforward. Let's now talk about how to do it. So this is by summing, right, with a sum. Let's talk about now how to do it with the max min version. So once again, read voltage max min. I'm gonna return a float because it's a decimal, right? It's a decimal. Like if you think about it, you add, let's say, two values that are not even, and then you divide it by 2. It's gonna give you 0.5. So we want to make sure that it's a float. And then the second thing we're going to do is the same thing. We're going to have a sample size of 1,000. But here's where it really becomes, let's just put return 0 for now. Here's where it gets actually a little bit different. So in the max min algorithm, I'm going to need a way to essentially store the maximum value, the minimum value, and the sample size. So I need 3 variables, and sample size here is n. Now I'm gonna do int max value I'm gonna set this to 0 for now, but I'll show you why this is not gonna work after. Int min value, same thing, 0. And here we're gonna do the same thing that we did for the other one. We're gonna loop 1,000 times. So same idea. I divided by 1,000. Sorry, less than 1,000. So it runs 1,000 times. And here's where it actually changes, and this is important. We basically need to make sure that we keep updating these each iteration. So we need to check if this new value that I just read is bigger than my maximum or smaller than my minimum. And if they are, I need to update my range, right? Because right now I have sort of boundaries, and I need to update those boundaries as I go. So for this, I'm going to create another variable that is just going to be current value. You don't need to initialize it to anything. I'm just going to say current value equals analog read right, we can't do a0. I forgot the rule number 1 in our second video, which was let's make our pins a constant variable, right? So constant temp sensor pin, and we are gonna say it's a0, and we're gonna use this all over the place. So over here and over here. You could assume that if I had a0, let's say here, and a0 here, and I changed my pins, now I manually have to change it all over the place, and that's really annoying, and that can cause a lot of errors. That's why we use variables, right? So I have my current value, I just read it, and now I have to check basically if that current value is bigger than my max value. Then I really want to update that max value, right? I want to store that new max, that new boundary, and I want to do the same thing for min value. Min value equals current value, right? So all I'm saying here is if it's bigger than my maximum, I have a new upper boundary. If it's less than my minimum, I have a new lower boundary, and this will allow me to have a better, well, this will allow me to have the range of values that went through that 1,000 iterations. So when we have this, once we have the max and the min, all we have to do is let's use parentheses, max value plus min value divided by 2, right? So if I have 2 boundaries and I want to find the somewhere in the middle, I have to do this plus this divided by 2 is going to give me the middle. Okay, now this is not going to work at first, and the reason why is because min value is set to 0. So what happens is, let's assume that I'm just gonna remove this. Let's assume I have 100 to 110. So I have these sort of values. I keep getting 102, 110, 103, and so on, right? So I'm getting these values. My maximum value is gonna get automatically updated on the first try because 100 is bigger than 0. So now my max value is this. Then 101 comes. 101 is bigger than 100. So because of my if statement, because 101 is bigger than 100, I'm gonna update my max value. So this is my new max value, right? Then 102, then 110, and 103 is not gonna do it because 103 is not bigger than 110. Right? So this remains our upper boundary in this set. But what happened with min? Well, min is 0, right? It's initially set to 0. So when I say 100, which is supposed to be my lower boundary, 100 is not less than 0. So this is never going to run. So my min value is always going to remain 0 if I do it this way, which is not going to work, right? So there's 2 ways of doing this. One way is the max value. You set the max value to a very big negative number, so a very small boundary, and your min value to a very large number. That's one way of doing things. The other way that I find a lot easier is I just set my my max and my min to essentially a number in the set. So I'm just gonna do in the sample. So I'm gonna do sensor pin. Right? And now what I'm saying is that, let's say I have a bunch of numbers like 100, 101, let's say 102 again, whatever. My min and my max are initially going to be set to one of these. it might be set to a minimum. There might be, like, at some case a minimum, there might be at some case a maximum, but it doesn't really matter because it's somewhere in that sample range. So if it's set to 110, the maximum is never gonna get updated, but that's okay because 110 is my upper boundary. If it's set to 100, my maximum will get updated, right? My minimum will stay at 100. And if it's 101, well, when it sees 100, it's gonna update the minimum, and when it sees 110, it's gonna update the maximum. So this allows me to, basically what you can do is you set your maximum and your minimum to something in the sample. If you have an array, which is what's important about this, because in your exam they might ask you to find the maximum and a minimum in a column matrix, for example, or an array. You can set the maximum and a minimum to the first index in the array, not the index, sorry, the first thing in the array. So let's say you have an array where I have 0, 20, I don't know, 10, 12, 30 or something. I can set my max and my minimum to 0, and that will work just fine, and I can just keep going through the algorithm and it will work and it will work out. So now that we've done this, I will say that this one is a little bit worse than the read voltage sum, and the reason why is because of the range. Let's say I have a it looks something like this, and then it does this, okay, and then it goes back to this. Now my maximum is this, and my minimum is somewhere here. So let's say this is like 10, and this is like 1,000 for some reason. The average is gonna it's gonna say that the average is somewhere here, when in reality, if you sum everything, it's actually somewhere here. This is a more accurate representation of the average than this red dot here, right? And so using the max and the min doesn't always, it's not always the best way to go about this. I would use a sum. Let's go ahead and read voltage max min, just so you can see that it somewhat, I mean, it still works out. It's just the values are a little bit less accurate, but it still works out. It's still pretty like what's it called, pretty stable, right? It's still a pretty stable value. It's just that it's a little bit less accurate than the sum. And the final thing, the noise level. This one's an important part because it's part of your final project, but also lab 3. It's how do you get the noise level in a function. It's actually very similar to the read voltage max min. You're gonna get the maximum and the minimum, and then you're gonna calculate, and then you're gonna use a specific equation that they give you. It's gonna be, I think, max minus min divided by 2 and square root of n. So if I just open the lab, just want to kind of show you guys the equation. Give me 2 seconds. I'm just gonna pause it and I'll come back when I have it. Okay, I'm back, and here is this is the lab assignment number 3. Here's the function they give you. So it's gonna be 0.5 times delta, which is just max minus min, as it's explained right here, and then divided by square root of n. So if we do that, well, first of all, it's the same exact method as the max min. We still gotta get it, so I'm just gonna copy paste it. There's no need into like I don't need to like redo it again. So this one now it's gonna be called noise level, okay? And n equals 1,000. This is the same exact thing. This is the same exact thing. The only thing that changes is the return. And here we're gonna do max minus max value minus min value. And we're gonna do times 0.5 divided by square root of n. And square root, thankfully, is a function in Arduino that the Arduino recognizes. And then I'm gonna actually print it. So I'm just gonna do noise level and upload this. And as you can see actually over here in over here, you're gonna have to use the servo and the light sensor, which is why again this is it's important to be able to see what the average is. So let's go to our serial plotter. Actually, let's just go ahead and open the serial monitor because it's very small values. So it's 0.03. Now you can see noise level is pretty low. Let's say I actually lower this to 20. So we just said 0.03, right? Let's go ahead and open my serial monitor, and you're going to see 0.22. So it just went from 0.03 to 0.22. And the more I play with this, the more I sort of mess around with the shadows and everything, you actually can see that the noise level increases, right? So yeah, it's just to sort of show once again how to determine noise level, and that larger sample size yield better results. It's just at some point you can't have like 5 million for n. It's never gonna work. Okay, now that we have done this, I think that's pretty much it for this episode actually. So if I open my serial monitor once again, 0.03, and even if I put my hand over, you can see it kind of fluctuates like 0.11. It doesn't go up to before it was at 0.45, right? So it shows that, I mean, sometimes you see 4.87. Where is it? Like, yeah, sure, but that's when I was moving my hand up and up like all over the place, which makes sense that the noise level would be insane because it's like this, right? But this goes to show, this just shows some useful algorithms. Most importantly, the maximum and the minimum. Being able to determine what the maximum and the minimum are, finding the average, and using, you know, a sum and for loops to sort of average out your analog input. These are all concepts that you're gonna see in your final as well, and you're gonna use for your final project. So yeah, that's it for this video. I think the next video I'm gonna talk about servos, and then I think that's gonna be pretty much it for this series. I have the first one, which is the introductory. Then I talk a little bit about Arduino, like the board and other standards that I use, the LED, we have the light sensor, and the servo. Those are like the 5 sort of main videos that we have. The most important thing that you should get out of these videos is how to use Google essentially to come up with ideas and solve problems. So, you know, here for example, we looked up how the photoresistor works, the circuit that you have to use, and we applied it, and then we did some code to get the average, right? So yeah, I'll see you guys next episode, and take it easy.